If I say terminal or command line, do you all know what I mean? Raise hands if you know what that means. Yeah, so it looks like pretty much everybody in the room does. Okay, so I'm going to be using the terminal inside VS Code. If you don't know how to do that, you come up to the top and say new terminal, and you get this little terminal down at the bottom. So I'll toggle in and out of that over the course of this presentation. I'm going to be talking about LLMs from the command line. So you may have heard of Claude Code or Open Code, tools like that. Those are like AI agents that will actually drive your command line for you. That's not what I'm going to be using here. What I'm talking about is a tool called LLM, which is a bit sort of like, it's like higher touch. So you more are in the driver's seat. You're still sort of using your terminal the way that you normally would use it. And you're just sort of making like individual calls to LLMs to accomplish things that you want to accomplish. So I'm not going to be doing like agentic workflows. It's more just sort of like one-off type things if you want something that sort of keeps you in the driver's seat more when you're in the command line. So this tool, actually first let me shill something before I get into LLM. If you haven't seen UV, UV is the new like hot package manager for Python. So if you've ever done like pip install, UV replaces pip. So you don't pip install things anymore. You would use UV. You would use UV add if you want to keep it sort of within project, or if you want to install something globally on your computer, you can do UV tool install. And the reason I'm shilling UV is because with pip, if I want to use something globally on my machine, usually you would do like a pip install global, and it's going to install that tool into your system Python, and now that tool is like part of your system Python where it could break your system Python installation, or it's going to be present every time that you use your system Python installation. It could like interfere with installing other things. You can get like version conflicts between different tools if you're installing things into your system Python. So what UV is going to do is it's going to create like a unique environment for every tool. So if I do UV tool install and then I install the tool, that gets installed into like its own little environment that's self-contained and that isn't going to cross-pollute between the different tools. And so it's just really nice it's going to get you out of Python dependency hell forever. All right, so like all of the sort of headaches associated with managing Python environments and dependencies go away if you use UV. So I highly recommend this. By the way, the things that I'm shilling in this presentation are not things that I have any stake in. They're just things I use because they're really good. This is the tool that I am going to be demonstrating in the presentation. It's created by a developer named Simon Willison. You may have heard the name. He's very famous. If you want to keep up with the latest AI stuff, you should subscribe to his blog. He's like super competent and knows all the latest AI stuff. He's vibe coded like hundreds of tools with the like Claude Code and other AI agent tools, and he puts together videos and blogs and stuff about how he does all of this. This tool you can install with UV tool install LLM if you've got UV installed on your system. So very straightforward install to get LLM. Okay. So so once you've got it installed, you also can install plugins for it to get access to different models from different providers. So like if I wanted to use DeepSeek models, I would do LLM install LLM-DeepSeek, and that would give me the plugin for using DeepSeek models. I highly recommend this one, OpenRouter. So OpenRouter is a service that is going to wrap a lot of different provider APIs under a single API. So you get one OpenRouter API key. Now you can use models for a lot of different providers. And one of the cool things about OpenRouter is that they've got models that are free to use. So when you list their models, you will see on some of the models a little tag that says free, and you can use those. You don't have to pay for them. So that's really nice. And then the last setup step, if you want to use LLM, is you've got to set your API keys for the different providers. So if I wanted to use OpenAI models, I would open my terminal and say LLM keys set OpenAI. It's going to prompt me to input my OpenAI API key, and I just paste my API. I go to the OpenAI website. I'd have to have an account, go to their dashboard, get my API key, and then I would paste it in. So hopefully you know how to get API keys. You've done that before. If you've used LLMs on your machine, you probably have gone through this process several times already. But I think it's fairly straightforward to get an API key. One sort of gotcha that I will mention is when you paste an API key into your terminal, often it will be invisible because the terminal is going to sort of, for privacy reasons, it's going to hide the API key. So you might think, oh, I tried to paste my API key in and it didn't work. No, it worked. It's just invisible. So that is one thing to look out for. All right, so I'm going to just show you the models. So I've got all those plugins that I showed you installed here. And to get the list of models available through LLM, I can go LLM models. Let me just expand this. So I've got my DeepSeek models here. DeepSeek Chat is fairly fast model that's affordable. We can see there's lots and lots of Open Router models. I get access to all kinds of providers with Open Router. Here's a 405 billion parameter model by Noose Research, which is free to use. So that's a really big model. Most of the time, if you're using a 405 billion parameter model, that would be a really expensive model to run. But if I use it through LLM, I can use it for free. So that's really cool. And then the default model for LLM is going to be GPT-4o mini. So the OpenAI models will be up at the top of that list. And if you don't specify a model, that's what you're going to get is 4o mini. Obviously, some of these model names are quite long. So I wouldn't want to type this whole model name, right? That would be kind of annoying to do. So I can set aliases, which are like short names for the models. So if I wanted to use this Quen72b instruct model, I would say LLM aliases set. I'd give it a short name, and then I'd input that really, really long name. And that lets me specify that model from the command line with this syntax. So I could just replace this thing here with Quen 2.5. And now I can use Quen 2.5. I think I've done this, but let me just remove this comment. We'll just run a couple of these so that you can see. So I'll run that. That should set an alias. And what did I do? No such file or directory. I may have. I'm not sure. Let's just. Let's try again. OK, so that set our alias, and now I can go LLM-M Quen 2.5, and I can just say hello, and it will reply to me, hello, how can I assist you today? All right, so fairly straightforward, I think, I hope. Couple of just like little points here on basic usage of this. If I use this -c flag, that means let's continue from the last message. So if I wanted to say, it said, how can I assist you today? I could say, I don't know, how can you? And since we're using that -c, it continues from the last message. And This is by the way, GPT-4o Mini now because I didn't set the model again. But it's just going to say, I can help with a wide range of tasks, and it lists the things that it can assist with. All right, so it's picking up from our last message, continuing the conversation. Another thing that I can do is I can, let's go to my folder here where I've got this file. With this -A flag, I can do attachments. So I can attach images, audio files, video files. Obviously depends on the support of the model that you're using, but as long as the model supports that file input type, you can do sort of like question and answer over files. So, and by the way, you can attach more than one file. So I could do 4 different images, and I could say, look, here's, I built 4 web components, and I want to know which one is prettiest. So I take screenshots of all 4, and now I'm prompting the model and saying, which of these web components looks the nicest? And it will give me, sort of assessment, visual assessment of which of the web components looks nicest. And you can build that into CI flows. There's all kinds of things that you can do. If I were like, I could scrape Twitter data and then, use LLM from the command line to like get an assessment of what is the image attached with this tweet, and I can attach that description as I'm loading data into my database. So, this becomes really powerful, I think, when you chain it with other tools. And I'll just demonstrate really, really quickly. GPT-4o Mini, which is a very small, cheap model, actually has image support. So I believe if we ask it to describe an image, yeah, so it's going to describe the image. You can see it says hosting capacity is a measure of agency. And let me just open up that image so that you can see it. And yeah, it's this graph of hosting capacity as a measure of agency. It's suggesting basically if you can host a conversation, you're lower agency. If you can host a congregation or a co-living neighborhood, you're higher agency. This is basically what the model is telling us here. So illustrates different types of gatherings, events, conversation, dinner party at the low end, co-living house at the high end. So, it's really good image understanding considering we're dealing with GPT-4o Mini, which is a very small model. So I think that's pretty cool. Moving on here. Here's some use cases, some ways that I use LLM personally that I'm going to walk through, and each of these use cases I'm going to demonstrate a feature of LLM using that use case. So one thing that I use it for is I was raised a Windows user, and I use Linux a lot now in my development work. I'm not like wildly familiar with Linux, and so I use LLM from the command line. If I don't know how to do something in Linux, I just say, LLM, how do I do this? Boom, answer right there in the terminal, And I can use templates to accomplish that, so we're going to talk about templates. I use a tool to pack my entire current development folder, and then I send it to LLM, and I ask questions about the folder that I'm in, the entire code base. It can do whole code base question and answering. I use it for progress reporting, so I feed it my Git log, and then I generate a visual report for my client to say, here are the stages of work over the past few months. Here's a report of all the work that I've done, and LLM can generate that for me very quickly. I use it for structured data extraction, so I use curl or the Google Chrome executable to grab a website. And then I pass it to LLM, and I give it a schema and say, return me JSON data from the website, extract JSON data from the website, and return it to me. And I can save that JSON data and then do stuff with it, do analysis over it. And finally, embedding in semantic search with just a couple of commands, you can generate embeddings. If you're not familiar with RAG, this is just RAG. With a couple of commands, you can do a whole RAG pipeline. And I'll talk a little bit more about what that is if you don't know what that is. It's super powerful, hot AI stuff, and it can be quite intimidating to get started with, and I think LLM makes it super, super easy to get started with it. All right, let's talk templates. So this is one way that I'm using LLM in my daily work. So I've got a system template, system prompt template, that says you are a Linux command line copilot running in WSL2, which is the Windows install of Linux, with the following Linux distribution. And then I can use this little variable syntax to actually dynamically get my Linux distribution and insert it into the prompt. And then I use that little save flag to say, save this as a template. And we're naming the template Linux. All right? And the system flag just says, hey, we're going to treat this as a system message. And then any prompt that I add in addition to that is going to be the first user message. So the model basically is going to see a system message that's this, and then it'll see an additional message that's the user message. Let me just demonstrate this really quickly. So we'll run this prompt and create this system, this template. And then we will ask it, how could I split a PDF by page range? Now, if I said, how could I split a PDF by page range, the model might say, well, you should use some Adobe product and do it in your GUI, right? But because I have this system message, this template, and I'm using the template by saying this flag at the end that says -- template Linux, it knows that I want to do this from the command line in Linux. And so the answer is telling me the Linux way to do it, the command line way to do it. And it gives me several suggestions, one of which is to use this QPDF tool. It tells me how to install it, and then it tells me the exact commands to run to accomplish that with that tool. So that's pretty cool. It makes it very quick to get answers about Linux. Now I can get answers directly in the command line without going to the web and doing web searches and so forth to try to solve my Linux problems. OK, let's talk about the whole repository Q&A. So this is another tool I use a lot. It's called RepoMix. All RepoMix is going to do is it's going to take everything in my current development folder. If it's checked into Git, if it's part of version control, when I run that RepoMix command, it's going to pack it into a single file with XML separators that are very LLM understandable, so it's AI ready. It's got, like it says at the top that, this is a packed representation of the repository. It's got all the file names in there so that the LLM can understand the file structure. It's got a map of the file structure, and it's all just ready for an LLM to use. Very handy. You can install it with npm. It's a JavaScript tool, so you can install it with this npm install g. The G flag says let's install it globally on the system, so I can use it anywhere on my system. RepoMix, all right, and then you just run RepoMix to pack the current folder. And once I've done that, which I will illustrate, I'll even show you the file so that you can see it. So it's going to run RepoMix pretty quickly. It's not instantaneous, but pretty quickly we have generated a file. And it looks like this. It's RepoMix-output XML. You can see the representation. It's got, obviously I have some images in here, so it's packed some images. If I want to do filtering, I'll show you how to do that in a minute, if I want to exclude certain things. But then I can just hand that off. Oh, and by the way, it'll tell you some sort of summary statistics. So I've got 4 million tokens here. That's going to be too long for any model to use, because most models have like a 1 million token limit. So I would need to do some filtering if I wanted to sort of get it down within LLM ingestible size. So let's just see how to do that on my next slide here. So I could do include, and then we can use these like globe patterns to say like what do we want to include. So I could say, let's just include like the QMD files that are in here. So include, I could do star.qmd like that. And much faster this time because we have way fewer files. And now we've only got 371 tokens. That's obviously much more manageable. So yeah, in fact, that's so small. I'm not 100% sure. Oh, 0 files. Yeah, so that I did something wrong there. It didn't get all my files. Oh, it's because I'm not in my root directory, and so it's not detecting this folder as a Git repository. So that's what's going on there. But anyway, so then I can attach the repo mix output as a fragment using this -f, and you can attach any number of text files as fragments, text fragments, and then you can ask questions about them. Okay, so like I actually could directly attach some of these files. So let me just say -f. Let's see, let's go LLM hackathon. By the way, this presentation is partly based on a hackathon that I did where we hacked on LLM, and we got a bunch of people. So I just attached that as a fragment without a prompt, and it's just going to kind of like summarize some of the things that people did for our hackathon. And it's got like we gave LLM Python tools. You can embed personal files for semantic search. You can chat with local models with LLM. You can add captions to photos with the vision model. You can chain it with other tools. So those are some of the things that we did for a hackathon. And I just got a summary by sort of attaching that file and asking questions about it. All right, next use case. I use this for progress reporting over my Git log. So this Git log syntax says, let's get the entire Git log since January 1st, 2025. I'll just illustrate for you what that looks like in my command line interface so that you can see what I'm handing off to the model. All right. So that's what it looks like. I can scroll through, commit messages. It gives me the dates of all the commit messages and so forth. This pipe right here means let's take the standard output, so the output that was printed to the terminal from the previous command, and let's pipe it to the next command. So that's what that pipe operator does, is it takes the previous output and passes it to the next tool. All right, so I can, let's just, last time I had some issues with those backslashes, so let's just take those out real quick. So I can pass to LLM that git log output. And then this -xl, this right here. So oftentimes LLMs will return to you what's called a fenced code block. So like if it gives me an SVG, it'll have it wrapped in backtick, 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 SVG, and then it'll give me the code, and then it'll have 3 more backticks at the end, and then it'll have some explanatory text kind of around the code, right? Which is kind of annoying if I'm trying to like do something with the code right away. Like I want to extract that code. I don't necessarily want all the natural language explanation that's around it. So how do I just like prevent that? How do I like grab just the code? Well, that's what this little flag does, is it says, you can do X, which is like if the whole thing is a fenced code block, let's just extract it. But this XL says, let's take the last, like if there's multiple code blocks, let's just take the last one in the response and let's extract that, okay? So, and then I can use this caret operator to send that to a file. So I can create a file named progress.svg, and we'll just extract the SVG code from the response and create a file from it. So if I run this command, I am calling a Chinese model here called GLM 4.6, because I found that one is pretty good for these SVG generation, and it will give me an SVG file. And it takes a little bit to generate that, but just to illustrate what that SVG file would look like, here is the output of that command. All right, so it's not perfect. We've got a little bit of overflow in the legend here, some text overflow, a little bit of overlap between the dot and the text here. But like overall, it's pretty good. This is a pretty accurate representation of sort of the commit messages in this repository and the stages of things that I've done and the timeline of when I did them. So I use this like fairly frequently to just generate reports to clients. If a client wants to know what I've done recently, I just pop that prompt in and get an SVG that illustrates. This is where it starts to get really cool for like data engineering kind of stuff. So we can extract structured data using curl to just grab websites. All right, so this is a tool that says like, hey, let's go to this URL and just print to the terminal the HTML from this web page, okay? And this is my GitHub followers, so I can just get all my GitHub followers and print it to the terminal. So this is pretty good for getting static websites. Curl will fail though on like React or JavaScript websites. If you've got Google Chrome installed on your computer, you actually can call Google Chrome from the command line, and you can get JavaScript websites and actually get the HTML for JavaScript websites. So I think a lot of people don't realize that you can do that with Google Chrome, but it's pretty cool. If you have to like create a symlink for your Google Chrome executable. So if you're on Linux and you've installed Google Chrome, you have that automatically. It's just Google-Chrome is the command line access for that. But if you're on a Mac or something, you've got to create a link to actually use your Chrome executable. But it's pretty powerful once you do that. This strip tags tool is just going to say, hey, let's get, if we've got HTML, let's just take out all the HTML tags and just leave the plain text. And it also removes all the like blank lines. So we can like take the curl output and just get the plain text part of it and leave behind all the HTML tags. And then I can pass to LLM, I just say extract followers, and then I give it the schema multi flag, which is saying like, hey, let's get an array of JSON objects with this schema. And we've got, ID, you give it, the name of the field, you give it the data type of the field, and then you give it like a description of what that field is. So I'm asking it to create an ID field that is the user screen name, and then a content field, which is the user bio. And you'll see in a minute why I chose that schema exactly. And then this JQ, I'm just using JQ to say like, hey, let's make a nice indented JSON, print it in a nice indented way. And also, when you get one of these arrays from LLM, it's always going to have this items key and an array of all the return data as items. And basically, I'm using JQ to say, hey, let's just select that items, let's unwrap it and just return an array like that. So that's all that little JQ thing at the end there is doing. And then I'm piping it to followers.json, so I'll just run that real quick and show you. Yeah, so I'm actually going to close this. Let's not save. But it takes a minute to do the curl request and get the HTML, and then it sends it to the LLM, and it will return our structured data. So then if I open that followers JSON, we see it has created this handy little JSON L file is what we call this. It's got multiple JSON objects in a single file because we unwrapped it. All right, so moving on to my next slide here, let's talk embeddings and semantic search. So if you're not familiar with the concept of embeddings, embeddings are like the key that makes AI work, all right? So we take natural language text, and we're going to turn it into a high-dimensional numerical matrix. So we're just creating like a like a mathematical representation of the meaning of that text, all right? And we call that an embedding. And AI, like one of the sort of core things that you can do with that embedding is that we can take two pieces of text, we can convert it to those numerical representations, and then using an algorithm called cosine similarity, we can say like, hey, how similar is the meaning of these two pieces of text? And if I have like 100 pieces of text, I can say, okay, like here's my search query, let's turn that into one of these high dimensional matrices, and then let's like sort of do that algorithm against every other piece of text in my corpus, so all 100 pieces of text, find which one of those pieces of text is the most similar in terms of meaning to the input string. And now I can do like fuzzy searching. So I might be looking for like something about the President of the United States. That might be my search query. And one of my chunks of text says something about Donald Trump. It doesn't mention the word president, though. So a keyword search would fail because president is not in the target piece that I'm trying to find. But Donald Trump, like the numerical representation sort of like reflects that Donald Trump and president are closely associated words. And so when I do my fuzzy searching, I'm actually going to find that piece of text about Donald Trump. And that's why this embedding stuff is cool. That's what semantic search does. It's like fuzzy searching. All right. With that JSON that we just generated, we can actually store that as text embeddings. So if you have a file, like 100 text files, you can just generate embeddings by like running this LLM embed multi over the whole folder. You can use a JSON input or you can use a CSV input. If you're using JSON or CSV, it has to have an ID field and a content field. The ID is just going to be an identifier, and the content is going to be what we embed. Okay, so that's why I use that schema that is ID and content, okay, is because I want to embed it. So I can chain these two steps. I can extract data from a website, and then I can run my embedding workflow over the data that I extracted. Let's see, where'd my, oops. Oh, yeah, 15 is the one we wanted. Okay. So first of all, you got to set a default embedding model. So that's what that step does, is we were just saying, hey, we want to use this OpenAI embedding model as our embedding model. And then I can use this command to embed my followers' data. And this is just saying, hey, embed multi. So we're going to embed a bunch of different pieces of text at once. And then we're going to name the collection followers. So that's what that is. And we're going to use followers.json as the input. And this just says, hey, let's store the plain text alongside the embedding. So rather than just fetching the numerical representation, we're also going to fetch the plain text along with it. So if I do this, it should embed that JSON file that we created. Oops. All right. And it happens, we've got, so clearly it returned malformed JSON somewhere. I might have to save it as a JSON-L. I know. What's that? Yeah, so what I think actually what I did is I should have extracted it as an array rather than items, because I did JSON-L rather than JSON. But if I wanted, actually I could, yeah, let's just run this and save it as an array. And then my embed multi will actually work. I've already got it embedded, but just take a second. Okay, so now we're ready to embed it. And very quickly, we have our embedding. And now with this LLM similar, this is how I do semantic search over it. So It's going to search my followers collection for data science. So this -C just means content is going to be data science. That's the content of my search query. And then the -N5, I want the 5 most similar results. And that does semantic search and returns the records, the followers, whose descriptions match data science. So essentially what I've done is I've taken my GitHub followers, I've said like, hey, let's extract their bio descriptions and see sort of how they describe themselves. And then I want to say like, okay, which of my followers are into data science? And I have run a similarity search for data science, and you can see I got data science aficionado, I've got senior data scientist. Data science, if I had done that as a keyword search, I wouldn't have got this senior data scientist because the phrase data science doesn't appear in this bio. But because the data scientist is very semantically similar to data science, our fuzzy searching has successfully returned that. Maybe even more so with machine learning engineer. I mean, data science is obviously related to machine learning, but I couldn't have gotten that with a keyword search. So that's pretty cool. And then we can chain our similarity search with an LLM prompt like this, okay? So this pipe operator, remember, takes the output of the previous command and sends it to the next command. So I can do my semantic search here for fine-tuning, and then I can ask the LLM to interpret the results for me, which of my followers is the best person to talk about fine-tuning. So this similarity search will return 10 items, the top 10 most semantically similar followers to my fine-tuning query. And then my prompt is asking for the one best one, all right? And if I do that, I get this explanation. Based on the provided data, the best person to ask about fine-tuning would be Christoph Schusch. They have expertise in reproducible research and scalable data workflows, which may involve fine-tuning processes. So I've got the LLM gives me who it thinks is the best person, and why are they the best person? Explanation of why. So that's pretty cool. I think like getting started with embeddings, usually you're using vector databases, and like you're probably plugging in with like Gemini APIs, OpenAI APIs. You might be writing a lot of custom code. This lets you do it with just a couple commands, which I think is pretty freaking amazing, actually. It really lowers the barrier to entry to getting started. And this is a video that I created about our hackathon, this link right here. So that will have more examples of things that we did in our hackathon, just to kind of give you the rundown. One person went to a website called Doctor of Credit, which has like bank like award programs. So he wanted to find out like which bank, like if I like open a new bank account and I want to maximize the bonus for opening a new bank account, transferring my money over to a new bank account, like what's the best deal? This website aggregates them all. He used curl to get the whole website, and then he used LLM to process the website and turn it into JSON data. And now he can do like, systematic, generate ratios and things on, the amount that you have to deposit and like the return amount, and get like what's the best deal. Okay, so another person took the so-called Big Beautiful Bill, the budget bill, Donald Trump's budget bill, and he chunked it. He just used a split. There's a command line tool called split that just chunks it into like 8,000 character chunks, and like saves each chunk to a text file. And then he was able to use that LLM embed multi to embed all of those chunks. And now he's got semantic search over the whole Big Beautiful Bill. You can do similarity search for agricultural policy, and then ask questions about what the implications of the bill are for agricultural policy, and it will look at sort of the top 10 results for agricultural policy and generate some kind of summary about what the bill says about agricultural policy. And like very quickly, with just 3 or 4 commands, you have now like very powerful tools for understanding legislation that you can use for lobbying or for blogging or whatever your goal is for understanding legislation. Very quickly you can do it with this tool. So go there, check it out. I think there were some cool projects for the hackathon. And basically, I think if you take LLM and you chain it with whatever tools you're currently using in the command line, like just think about what are the tools that you use daily, how are you using them? Probably if you chain them with LLM, you can like make it like way more powerful. And you can find interesting things to do with AI and ways to integrate AI with whatever you're already doing. Questions? Yeah, thank you. Any questions? Yes.
When you were doing the example with, I think it was called
Quinn, yeah.
When you sent a query to Quinn 2.5, and then you followed it up with a query using the context for the previous one. But I guess my question is, did you use the context from your conversation with Quinn and then send that to OpenAI 4.0?
Yes, yeah. So the context is going to be stored locally. Actually, LLM is storing all of your logs in a SQLite database. So if like later you wanted to go back and be like, hey, a week ago I had a conversation with an AI model and it told me this, you actually can find that in your logs. So that's pretty cool.
Does that mean that you can artificially make contexts and use that for your own queries?
Oh yeah, I mean you can do that like in general with AI models. LLM does not provide like a simple way to do that, but you absolutely can create like fake conversation history with AI models, and this is a common jailbreaking technique. So like you want to get the model saying yes to your query, and so if you have some query that's like prohibited, then you create a fake conversation history where you're asking those prohibited questions and the model is answering them, and now the model, you're sort of leading the model toward like being in a willing mood to answering your forbidden queries. And so a lot of jailbreakers will do that. They'll create fake conversation histories where the model is already saying yes to their prohibited queries. Yeah, that's definitely something that you can do. Yeah?
Are you familiar with Puppeteer, the headless browser?
Yeah.
You were using something besides Puppeteer.
Yeah, so curl is simply making an HTTP GET request to a website. And if you have a static website, that works great, because it's just getting the HTML for the website. If you've got a React website that is dynamically rendering a website, a curl request will simply get the JavaScript. It won't get the HTML that would then be generated by the JavaScript. So a lot of people will use Puppeteer to like wait for the JavaScript to render and return the HTML, and now we're like trying to, they might even perform some like, they might log in on the website using Puppeteer in order to like get to a page that's behind some kind of authentication gateway. So yeah, I mean Puppeteer is a tool for if you're doing something more complicated than simply getting your GitHub followers, you might need a tool like Puppeteer where you have to do some browser automation to kind of like get to the content that you want from the command line. I suggested that you can use Google Chrome to get JavaScript websites. So I didn't show it, but you can just say Google Chrome headless. You just add a little option flag that says headless. And you call Google Chrome and you give it the URL, and then it will, and you say dump DOM. So it's going to wait for the website to render, and then it will dump the HTML, the rendered HTML into the command line. So if you don't want to mess with like writing Puppeteer scripts in Python or JavaScript or whatever, you can use Google Chrome from the command line, and it will, as long as you don't need to log in or you don't need to do any automation logic on the browser, it will render a JavaScript React website and give you the HTML. So I think that Google Chrome is a nice like sort of intermediate step between curl, which is very simple and not very powerful, and Puppeteer, which is like your more powerful solution that requires some scripting to do things with. Yeah. Yeah.
Is there a model that looks like yourself?
It depends a lot on what I'm doing. I find GPT-5 to be the best coding model, but it's terrible at interpreting. It's like incredibly autistic model. Like it's really, really smart. It can do the mathy, codey stuff really, really well, but it cannot, for the life of it, explain to you how it works in like language that you can understand. It's just like, not a good communicator. So often what I will do is I will have GPT-5 write code, but if I'm writing documentation, I'm going to Claude, So Claude 4.5 Sonnet is the one that I tend to use for that. As I had mentioned, GLM 4.6 is great at SVGs. I have not, models, most of the frontier models are actually shockingly bad at SVGs. And I'm sure the people who trained Quen, a Chinese company called ZAI, I'm sure they did a bunch of synthetic training on just SVG data, and just for whatever reason, that model is good at that task. So yeah, it really depends on the task, and more I'm finding particular LLMs are really good at specialized domains, If I'm doing PDF document understanding, I'm using .ocr, which is you've probably never heard of it in your life, But it's just some tiny little startup created this incredibly good OCR document layout model that just happens to be the best in the world right now. And the only way that you would know that, honestly, is by using them and benchmarking them and for whatever your particular task is. And the landscape changes all the time. So yeah, I think it's more and more it's important to either have sources of people who are benchmarking models or be doing some benchmarking yourself over whatever your task is. Yeah?
Earlier you mentioned the whole list of different models that we can use against adjusting the API keys for it. Are these all paid API keys or is it free?
So the Open Router one, you do have to get an API key to use Open Router models because they're tracking your usage and so forth. But if you list the models that are available through Open Router, they have a lot of free models. And so you just look in the models list for the free tag at the end of the model name. And as long as it's got that free tag, it'll be free to use. So probably we'll have to provide a credit card or something to Open Router to be able to get an API key. But as long as you're using those free models, they're not going to charge your credit card. So yeah. And I think, in fact, I don't think it's a accumulate usage and then pay later. I think it's you pay up front, so you load $10 onto your API key, and then they subtract as you use stuff. So I don't think there's any risk of getting accidentally charged through Open Router. If you don't have money on your account, it'll just say, oh, you don't have enough money to use this model right now. Yeah?
Have you tried using any VS Code extensions that use AI instead of this method?
Yeah, so there's one called Klein, which is the open source version of Cursor. I don't know if anybody here has used Cursor, but Cursor is an AI-powered IDE that's got lots of agentic coding stuff in it. If you don't want to pay for a Cursor subscription, you can use Klein, which is just a VS Code extension. And it's essentially Cursor, but it's using your API key. So if you've got an OpenAI API key or an Open Router API key, you just put that API key into Klein, and it's going to charge you by usage, whereas with Cursor, you would pay a $20 a month subscription. So if you're just experimenting, or you're not doing that much coding, and you just want to pay a little bit here and there for your API usage, you can use Klein. So that's one that I find pretty useful. I think the other thing that's key with using AI tools in your IDE is have linters installed, type checkers. So I have the Pylance extension set up to do strict type checking. And then the nice thing about that is that then that gets imported by the AI model. If I'm using Klein or Cursor, that gets used as context for the model, and now the model can see, oh, there's type errors in this file, let's fix those type errors, So you're just sort of using the extensions to create context for the model that sort of helps steer the model and check and make sure that it's not making errors. So yeah, that's kind of how I'm using extensions. Yeah?
I
I just wanted to say that like, when you mentioned type checking,
Yeah.
check out rough and type from Haskell.
Yes, actually, I have been using Thai more and more. I find that Thai is a little bit less aggressive than MyPy, so I've still been tending to use MyPy because Thai like misses some stuff that I want and occasionally throws some false positives that I don't want. So it's still in development. You know, it's unstable. But the nice thing about Thai is it's way faster than MyPy. So I think once they get it to, it's made by the same people as UV. I think once they get it to that level, you know, it's going to be the go-to type checker in Python, I think.
Nice. So MyPy is still more accurate.
For me, yeah, I have found I'm still using MyPy for the most part, yeah. Any other questions? All right. Well, thank you so much for coming.